Hello, it's Keith here, and this is lesson 55 of the platform-specific series of my 68000 assembly programming tutorials. Today we're looking at getting some music playing on the X68000, but we're not actually particularly looking at the music today. I've covered music in ChibiTracks and ChibiSound Pro tutorials. We're using that previous music driver, and we're going to actually set up an interrupt, a timer-based interrupt that works on the VBlank so that our music plays at consistent speed. So that's what we're going to be looking at today, and we're going to go into it. Now, it was a bit of a challenge getting this working. Basically, I had to read a bunch of manuals that are in Japanese. I can actually read Japanese, but I'm not so much of a fan of reading technical manuals in a language that isn't my first one. But anyway, there's a lot of technical details, a lot of different ports that are related to this. All of the interrupts that we're looking at today are generated by what is known as the MFP. Now, there's a wide variety of them, but all we're going to look at is the parts that we actually need to use to actually get the job functioning today. So there's a lot of details that we're not going to go into. You can see I've made a list of the ports and the various bits of those ports here. Now, after a lot of confusion, I eventually figured it all out. And basically, when we set up one of these interrupts to occur, it's the VBlank that we're going to be using today. But basically, the interrupts actually go to a vector address within the low memory area, which we can actually write to. On some systems, it would be ROM, but we can actually change those addresses. So basically, the addresses from memory address 100 onwards are various user interrupts for various devices, and basically the memory address 100 is known as vector 40, and that is the first of the MFP interrupts, and basically the bottom nibble of that vector number 4, the 0 in that 40, means that this is interrupt 0, this is interrupt 1, and it's actually interrupt 6, which is GPIP4. Unfortunately, it's not GPIP6, would have been a lot clearer, but it's for GPIP4 that is the VBlank interrupt. So it's this memory address that we want to put our interrupt handler at to get it to execute during the VBlank interrupt. And then all we need to do is we need to set up the interrupt control, and we need to set the interrupt mask, because the mask would disable the interrupt, and that will get our interrupt firing as we need to play the music in a consistent way on this system. Actually, the code to do it is very straightforward, but I can assure you it was a bleeding nightmare getting it working, because as I say, I'm reading these Japanese technical documents and I'm like, I'm kind of understanding what I'm saying here, but reading them in English is often a struggle for me. So as I say, reading them in Japanese was not something I wanted to do. Anyway, let's have a look at the results of all of that reading and let's see what we got here. So basically, we need to only do a relatively few things here. Now, there are two sets of interrupts that are available to us. There's two registers, each is only 1 byte. The first of these is at E88007, and that is control A. And then the second one is E8009, and that's control B. Now, these have 8 bits each, and these bits are actually matched for all of the similar functions. So enable and mask all use the same bits in the same positions, which is at least something that's convenient for us. So the first thing we're going to do is we're basically going to disable all of the interrupt control A interrupts by writing a byte of 0 to E88007. That's disabled those interrupts. And then we're just going to turn on GPIP4, which is controlled by bit 6 here of E8009. So that is enabling the VBlank interrupt here, at least in theory. So that's the interrupt control at E8009. But we also need to set the matching mask, because if the bit is 0 in that mask, the interrupt won't fire even though it's enabled in the control. So we're doing that. We're using the same bits. E8007 was the control A, E8013 is the mask A, and E88009 was control B, and E88015 is the second mask set. So here we are enabling the mask for the interrupt. Now, if we change this to 0 here and we run again, no sound. We have no sound, and that's the kind of thing that was catching me out with regards to getting this working in the first place. So there we go. So that's how we actually set up the interrupt to fire. Now, the only thing that's left to do is to actually install our interrupt handler. And as I say, the interrupt we're actually having occur is interrupt number 6, which is at memory address 000118 in the low memory area of the traps of the in the vectors in that memory address. So all we do is we write the address of our interrupt handler to that address, and it will now be executed when VBlank occurs. It's really straightforward once you understand it, but as I say, I was really struggling because there were all these kind of things that were confusing me, and often on these kind of systems you can't write to these kind of low memory areas. It'll be protected, and it'll be ROM or something, so I wasn't even expecting to be able to change those low memory areas, but you apparently can, so that was surprising. Anyway, so that's how we get our interrupt to occur. Now there's one other thing that I'm just going to very quickly cover. We don't actually need to do this, but being as I'd read all of that documentation, I will cover it. Now, as I say, the interrupt vectors start at memory address 100, and that is known as vector 40 in hexadecimal. Now we can actually change that to a different set of vectors. Basically, the top 4 bits of E88017 define the vector address, the top nibble of the vector address, with the bottom nibble being the number of the interrupt that occurred. So if we change that 40 to a 30, we would then end up executing a totally different memory address, and we'd probably get a crash actually, because we've got no interrupt handler there, or nothing would happen. But we can do that if we so require. Anyway, that's all it takes to get the VBlank interrupt working in a controllable way. So now what we're going to do is we're going to quickly discuss ChibiTracks. ChibiTracks is my multi-platform music player. It exists for the Z80, 6502 and 68000, and it's the 68000 we're looking at today, of course. Now, it needs 256 bytes of RAM on the 68000 system, a little bit more than the 6502, but we're defining some variables here. These are used by the player. And so we're defining these as part of the Chibi Sound RAM here. And then basically during our interrupt handler, all we need to do is we just need to run the play routine. We're backing up and restoring all the registers so that none of them get changed, because ChibiTracks uses pretty much all the registers. And then one other thing I should have mentioned is our interrupt handler does need to return with an RTE command, not an RTS. If we try and do this with an RTS, well, we're going to have a pretty bad day here. Let's see here. We've got a crash, and that's because we've not the RTE automatically. I believe it pops the flags off the stack basically, so that's why we have to do that. Now, apart from the memory of the Chibi Sound and ChibiTracks, of course, we need some software. So Chibi Sound Pro is the platform-specific driver. So this is the bit that handles the 68000. The X68000 peculiarities in a common way for the other systems. ChibiTracks is the actual player, and there's some shared modules here that I plan to reuse later on, so those are included. Of course, we need a song file, and here is the binary song file we're playing today. And it's important to notice the binary song file will play on any system that ChibiTracks supports, because of that hardware abstraction function here and the multi-platform player. So that's the benefits of ChibiTracks, if you will. It's not the best music player in the world by a long way. It is very convenient though. Now, all we need to do to get the music to play is we need to initialize the sound driver. So we run Chibi Sound Pro init once at the start of our program probably. We only need to run that once. We then load the memory address of our song to Songbase, and we run start song. Now start song will then configure the various variables of the song. Now I've actually made an override to the song speed here. I've changed the song speed to 6. The default is 5, but that would actually be too fast on this system, because this is a 60 Hz system and the song was originally made for 50 Hz one. So I'm overriding the song speed here, and that changes the playback speed. Then once you've done that, all you need to do is keep running ChibiTracks play at a constant speed to update the music. In this case, I'm using an interrupt handler, but if you were doing something very simple, maybe you could just use a simple delay loop, but that's all it takes. Anyway, that's all we're covering today, so there we go. If you've liked what you've seen, please like and subscribe. If you want to support me, you can buy my book. I have a book on 68000 coding and loads of others. I've got 2 books out now, and I'm hoping to do a 3rd next year. Anyway, if you want to see more 68000 tutorials, please consider backing me on Patreon, because as I say, it took basically 2 full evenings, about 6-7 hours work of research trying to get this example working. It's only a 10-minute video, but it takes hours to do in the background. So if you want to see more, please consider backing me. Anyway, hope you've enjoyed what you've seen today. Go to the website, download the source code and the build scripts, and as I would say, you're welcome to use anything from the code in your own projects, even if they're commercial. Anyway, I hope you've enjoyed what you've seen today. Thanks for watching, and goodbye.